Hey guys, Pankaj here. Welcome back. In the last video, we talked about covariance, right? And we saw like how it works and what is the drawback of that covariance and how to work on from that covariance drawback using Pearson correlation. Okay, so we'll see that and we'll see how it works and what is the drawback in Pearson correlation, how to overcome from that. For that, we have something called Spearman rank correlation. Okay, so let's talk about this. So today it is going to be a little theory and some mathematical formula. No Jupyter notebook or no Python code. Okay, so let me share my desktop and start explaining about it. Okay, so let me recap what was covariance so that you guys can understand what was happening in covariance and what is the limitation. Okay, so we saw that if any, we have, let's say, two random variable x and y, right? And if x is increasing, then y is also increasing, then we have positive correlation, correct? If x is increasing and y is decreasing, then we have negative correlation, correct? And if x is increasing and y, there is no variance, there is no change basically, right? So we have zero correlation. Okay, or maybe very close value to the zero. Okay, but how it was working? So let's talk about this once again. So let's say you have one straight line here and your data is located very near to the axis, these values, correct? Okay, and let's say mu or nothing but the mean of this data was somewhere here, and mu of or mean of y is somewhere here, mu of y and mu of x, correct? Let's say we have one data here x1, and corresponding to this your y data is somewhere here. Let's say we just talk about y and okay, y1 and x1. Okay, and one data is somewhere here. Okay, we'll talk about this later. Okay, so when x is here or x1 is here, then what is corresponding value? Y1, right? So we saw covariance, how to calculate. Basically, n I equal to 1 to n, and it was xi minus mu of x and multiply by yi and mu of y, or basically mean of y. Okay, divide by 1. This was the formula. Okay, so how basically this works, this formula, how it works. So if you are going to put the value, let's say xi minus mu x, right? So xi x1 minus mu x, if you do this, definitely it is going to be positive, correct? Why positive? Because x1 is greater than mu x, correct? Similarly, y1 minus mu x, if you do, it is going to be positive, correct? If you multiply those two, you are going to get positive value. Okay, if it is positive means we have positive correlation, and this positive correlation tells that we, when x is increasing, y is also increasing. Okay, so that's how it was happening. Now let's take another value here. So I'm going to take another color and just represent the data. Let's say you have another value is somewhere here, x, what do you say, 2, and corresponding value is y2, correct? So now in this case, what will happen? X2 minus mu of x and y2 minus mu of x. So x2 is smaller than mu x, definitely it is going to be negative value, and y2 in this case, it is also smaller than mu of y, and this is also going to be negative. If you take the production of this, what will happen? Ultimately it is going to be positive. Okay, so it means if x is increasing, y is also increasing. So this is also having positive correlation. Okay, so that's how this, if you are feeding those values in this formula, those are going to get or those are going to return some value in positive and negative. Okay, let me show another example now where this was like, it was clearly showing positive relation, correct? Now let's talk about another graph. So so you have another data here, x and y, correct? And your data points are, let's say this, you have, sorry, let's say one regression line is like this, or data points are located like this. Okay, so what is happening here? Let me draw the mean here. So let's say mean of mean of x is somewhere in the middle, and corresponding mean of y is somewhere here. Okay. Now in this case, let me take one value. We have, let's say, x1 here, and their corresponding value of y1 is here. So what will happen? X1 minus mu is going to be, x1 is greater than mu, so this is going to be positive, and y1 minus mu, so y1 is lesser than mu, right? So this is going to be negative. If you take the product of this, what it is going to happen? It is going to return negative. So that's why it is called negative correlation. Okay. Now in this case, let me take another value here. Let's say I have, this is your x2 and this is your y2. So what will happen? X2 minus mu. So x2 is lesser than this is going to be negative, and y2 minus mu, y2 is greater than mu, so this is going to be positive, correct? And if you take the product of this, what it is going to return? Negative value, correct? So it means negative correlation. That's how, with the help of formula, if you are putting or mapping those values, you are going to get exact positive and negative correlation. Okay, but there was a drawback of covariance, right? When you change the, let's say we have x represented in, let's say, centimeter, okay, and y represented, let's say, weight in kilogram. Okay, when you change the unit centimeter to, let's say, feet, let's say height of a man or height of any particular person, right? And this kilogram is changed to pound, that is nothing but lbs, correct? So what will happen? Let's say this covariance was positive, but it's not necessarily like this is also going to be positive, but this is what we assume, right? It has to be same. We are just changing the unit, correct? So in this case, it may be negative or it may be positive, correct? So those kind of thing you cannot predict until basically whenever you are changing the unit, right? So this is not going to be same as what covariance you calculated here. So this is a major drawback of covariance. Okay, so irrespective of this, if you are going to have same, then we are going to solve this problem with the help of Pearson correlation. Okay, so what Pearson correlation does, let me go to another whiteboard and just talk about this. So Pearson correlation, what it tells, basically, let me represent PC, that is nothing but again 1 upon n, I equal to 1 to n, and it is nothing but the, sorry, this was the covariance, right? So we have covariance of x and y, and divide by standard deviation of x and standard deviation of y. This is nothing but multiplication. Okay, that's how you calculate the Pearson correlation. Okay, so if you have any data, any random data of x and y, and you want to find the covariance with the help of Pearson correlation, you calculate the covariance between x and y, which we have already seen how to calculate, and divide their value by sigma x and sigma y. Okay, so let me just show one graph here. So how it is basically doing that. So whenever you have this kind of graph, right, you can clearly tell this is like perfectly negative correlated, and when it is not exactly straight line, but your data is from the regression line, it is little spread, a little wider spread, right? So their value will be, again, it is negative, but their correlation, Pearson correlation, tell that your value will be between, let's say, PC greater than equal to 1 and less than equal to. Okay, so your PC or Pearson correlation coefficient will be only between -1 to +1. So that's what it is going to say here. So whenever it is perfectly aligned, let me just use one color here. So let's say you have color like this. I mean, your values are perfectly aligned, right? Just a minute. Okay. So values are perfectly overlapping on these lines, right? So whenever it is perfectly aligned, then it will show exactly either -1 or +0 or +1. When values are, spreading or little wider from the main line or from the regression line, this value is going to be 0 to -1, okay, or -1 to 0, you can say. And this P is nothing but your PC, that is Pearson correlation. It is represented as rho. This is known as ROH. Okay, this is rho. Okay, when let's say you have a straight line where when X is increasing and Y is also increasing, but it is not perfectly overlapping on the line. So your value will be between 0 to +1. Okay, similarly here also it is perfectly overlapping on this line, right? Your Pearson correlation coefficient will be +1. But what about in this case? There is no relation, right? So you will see Pearson correlation at 0. But there is another drawback of Pearson correlation. Let's see what is the drawback. So far what we saw, right? Those data were nothing but your linear data. So let's say X is increasing like this, or X is decreasing, but X is increasing, but Y is decreasing, and there's no relation at all. Very much, straight line. So this is called as linear. Okay, linear relation. Okay, what about data which is, some kind of spread like this? It is non-linear data, right? You see here, it is increasing, then decreasing, again increasing, right? When you plot like this, and this is circle, and a lot of data is spread like this, correct? So what about this kind of data? That's where your Pearson correlation will fail. Okay, it is not going to show exact relationship. But if you see here, uh, data is increasing and decreasing, right? It is non-linear, so your Pearson correlation will not be giving an exact value, like how it is correlated. To understand that particular data, we have something called Spearman correlation. Okay, so that we'll see now. And if you have data anything like this, let's say you have some data which is, going like this. Okay, so in this kind of data, you'll see there are some area where whenever X is increasing, but you don't see any increment on Y, correct? So let me change some color here. So let's say I'm talking about this data. Okay, here it is perfectly clear, like X is increasing, Y is also increasing. Here X is decreasing, and X is increasing, and Y is also decreasing. Okay, so in this particular case, what happened to this? You will not be able to exactly tell whether it is increasing or decreasing. It is very straight, very much a straight line. So in this kind of sample, what happened? Your Pearson correlation is not going to get accurate value. It may provide some value, but it is not accurate. When I say not accurate, means by looking at the graph, you can tell when X is increasing, my Y is also increasing. Okay. So in this case, what happened? Whatever data you have for X and Y, you calculate the rank. Okay, so once you get the rank, and based on the rank, you do covariance and divide by standard deviation of rank, then you'll get the exact value. Okay, so maybe Pearson correlation may, so it is 0.8, that coefficient, right? Because it is not perfectly linear, right? It is non-linear system or non-linear graph, I would say. Okay, so for such non-linear graph, Pearson correlation may not give accurate value or accurate correlation. But when you talk about Spearman rank, this may be exactly 1. Okay, so for such kind of non-linear graph, Spearman correlation is very helpful. It is going to give the perfect relation between X and Y. Okay, so let's see the graph here, how it looks. This is what I was talking. So let's say you have some data, non-linear data like this, right? So what is happening here? You can clearly see that Pearson correlation, when calculated, it was showing 0.8, right? But Spearman, it gave exactly 1. Why? Because it's monotonically it is increasing, right? Okay, it was not like a straight line, correct? The straight line was straightforward, and we got like it is positive correlated. But for such kind of non-linear data, it is monotonically increasing. Okay, so for this kind of cases or this kind of non-linear data, Spearman correlation will be very helpful, and it is going to give the perfect relation between that data. Okay, for this kind of data also, I mean, you may see 0.37, but it is 0.35, so very much close, like Pearson and Spearman both are same. But what about this data? We also see monotonically it is increasing, but here we see gap, and again you have some data, right? So Pearson correlation may not give exact correlation, but Spearman correlation will return perfect related relation value between X and Y. Okay, so let's see the example here. Okay, I'll explain with the help of whiteboard. So what you do basically to calculate the Spearman correlation, we have something called, so let's say you have X and Y. Okay, so X is nothing but, let's say you have something called a 168. This is nothing but height. Okay, and this is nothing but weight of a person. 168, 158, 120, maybe 140, and let's say 200. Just assume that. Okay, and here we have 50, we have 80, and maybe 30, 60, and maybe 85. So what you do, basically you calculate the rank of X and rank of Y. So rank means it is nothing but the sorted. Basically you need to calculate sorted or order value. Okay, so what exactly it means is it is going to put in ascending order, right? So what is the minimum value here? 120, right? You just put 120 here, and whose rank is 1. Okay, after that 120 we have 140, put 140 and rank will be 2. Then we have 158, put 158, rank will be 3. Then we have 168, rank will be 4, and 200, rank will be 5. Similarly for Y, that is nothing but your weight. So what is the minimum value? We have 30, right? 31. Then after that we have 50, take 50, give the rank as 2. Then we have 60, give the rank as 3. Then we have 80, 5, and 85 as 5th rank. Correct? So once you get this rank right, all you need to do is Spearman rank equal to, I'll just give covariance of X rank and covariance of XR and YR. Basically rank of X and rank of Y divide by standard deviation of rank X multiplied by standard deviation of rank Y. Okay, so once you get this data, it is going to tell what is my Spearman rank correlation coefficient. Okay, that's what you are going to see here. This particular value, right? Whatever we just saw in this graph. Let me just close this color. Yeah, so you may get 1 here, and for other nonlinear data, you will get 0.84 and all after putting all the values, after calculating the rank. And this is what is shown exactly here also. Okay, so you got some X and you got some Y, calculate their rank and put in the formula. You are going to get Spearman correlation coefficient. So this is going to be helpful whenever you see such kind of non-linear value. Okay, so I'll just show how exactly this to be calculated. So what I'll do now, I'll take some value here, and we have something called, let me create a data frame. Okay, because in pandas those functions are very much I mean it is very easily available, and we'll just use them and just calculate the correlation coefficient. Okay, so df, let's create df pd dot data frame from a. Okay, and df is nothing but this. Okay, you got some value, a range between 1 to 100. I just took some normal value from 1 to 100. Okay, after getting the value, how you can calculate that? So basically we have something called df dot correlation. Covariance we saw yesterday, right? So you can directly get that. This is a correlation. Df dot correlation. It is going to get or provide by default what is your Pearson correlation. If you take the help of this, right, we have Pearson correlation. Now let's say you have got some non-linear data. So for that, we know Spearman rank will be very helpful, right? It is going to provide the perfect correlation. So you can use method equal to Spearman. In this case, it is coming 1.0 because we have not taken any random, right? It is just serial number. Okay, so that's how you calculate, and based on that, you can understand which is perfectly showing the relation between X and Y. Okay, guys. So yeah, that's all I wanted to talk about Pearson and Spearman correlation. I hope you got it. And whenever you go, you do some exploratory data analysis, you plot the graph, and by looking at the graph, you can clearly tell whether it is linear relation or non-linear, whether it is positive relation, negative relation. If it is non-linear, then probably you can get the DF correlation or with the help of Pearson or Spearman. Okay, then accordingly use the, actually you need to plot it. By plotting only you will get to know whether we need to use Spearman or Pearson. So by default Pearson, because we assume that data is linear. What if data is non-linear? You change the method as Spearman. Okay, so that's all for today, guys. Pearson is done and Spearman is also done. I hope you understood. And remember this formula. If you seen this graph properly and how I calculated, then remembering formula will be very easy. You also just calculate and see how it is working. Okay, guys. So that's all from my side today, and see you in the next video. Thank you so much. Bye bye.